Good evening, everyone, and welcome to the Canberra AWS user group for June 2020. My name is Brian Farnhill. I'm a developer specialist with AWS, and let me give you a quick run through of what we're going to go through this month. So, on the agenda is our usual run through of what's new in AWS. We'll talk to you about where you can find online training. We'll go through a little bit about some of the new white papers that have been released this month, and then into our main presentation of Andrew Hammond talking to us about how we monitor truck driver fatigue with the help of AWS. It's a cool little solution that the team have built there. So, what's new this month in AWS? Just a lazy 119 new things so far. We'll see what happens before the end of the month. As always, we do like charts. So for those playing along at home, here's what that one looks like. Now, my top 10 for this month, things that I want to take you through. The first one was an update to Amazon S3. So S3 has the ability now to show you access history of your actions. So what this means is it makes it really easy for you as someone who's working with IAM permissions to identify unused permissions to S3. So if you've over-provisioned access. So this means that it's easier for an administrator to be able to figure out where you've done that so that you can then tighten things back down and really minimize the permissions to your S3 buckets. Next is a feature for AWS Direct Connect. We've added the ability to test failover. So if you haven't already seen it, the Direct Connect Resilience Toolkit is worth looking at if you're administering a Direct Connect. But what got added this month is the ability to essentially terminate a live BGP session, which would simulate the failure of one of your connections. So this gives you a really great way to test your routing and your failovers without having to actually physically unplug anything or do anything like that. Okay, next, CloudWatch Application Insights now supports MySQL, Amazon DynamoDB, custom log sources, and a bunch more stuff. So Application Insights was a platform that we released for .NET developers, specifically around .NET performance and Microsoft SQL Server performance initially, to give you recommendations of slow-running queries and where you could help optimize your code that was running inside of AWS. Now, Application Insights has the ability to dig into MySQL logs, DynamoDB logs, as well as a bunch of other custom log sources to interpret performance data and help you identify patterns of errors and things that might need to be investigated further. So if you're a .NET developer running in AWS, Application Insights is absolutely one to go and look into. Next, we have a new service, one that developers might want to pay some attention to. It's AWS Code Artifact. So this is a fully managed software artifact repository. So if you're, like me, if you're a Node.js developer, you'd be very familiar with interacting with NPM and downloading NPM packages. Now you've got the ability to run your own serverless, fully managed repository for NPM packages. And you can also do this for Python and for Maven. And so you can publish your own packages as well as set upstream providers. What this does is it makes it really easy to audit different packages that are being used by your developers, as well as providing you with a private way to share internal packages where you don't have to go through and set up your own server to do that. So this makes it much easier to follow some really good practices around package management and versioning and releases without having to manage your own package repository servers. So this is definitely one to go through and have a look at. Next, Amazon Cloudfront enables configurable origin connection attempts and origin connection timeouts. So what this means is if you've put Cloudfront in front of a web application of some description that you're operating, now you can actually configure how many times Cloudfront will attempt to establish a connection on your behalf and what it will wait for in terms of a timeout there. So this is really good if you start looking at where you can leverage Cloudfront's ability to fail over from one origin to the next, where you can specify that requests, if they can't be satisfied by the first origin, should be then sent to the next one. It gives you a really great way to manage a really graceful degradation of service so that if your server comes under load and temporarily isn't able to handle responses, Cloudfront can redirect them to some other, perhaps temporary error message or some other system that's able to perhaps queue that for later response. So again, it gives you more control over how that's going to work in your environment. Next, Amazon EKS now supports the EC2 Inf1 instances. So we've talked about the Inf1 instances a couple of times now since they got announced at reInvent last year. Basically, these are EC2 instances that are powered by the Inferentia chips, which have been designed and built by AWS to provide the most cost-effective and best performing machine learning inference in the cloud. So now, if you're running an EKS workload that is being used to infer things out of machine learning patterns, you can use these Inf1 instances to improve your performance in doing so. Now, there's an updated AMI for deploying stuff into EKS here that already has the AWS Neuron network deployed into it so that you can use that to make those calls out of EKS. But this is a really great solution for anyone who's running a Kubernetes-based workload for doing machine learning. Next, one for the infrastructure as code people. There's a new CLI tool that we've announced called AWS CloudFormation Guard. So this is in preview at the moment, and essentially what it is an open source CLI tool for validating compliance of CloudFormation templates. What that means is you can generate a rule document, and if you don't want to write that from scratch, there's a separate CLI that will generate a rule document for you based on an existing CloudFormation template. But then use that rule document against your CloudFormation template so that you can validate that it's compliant with whatever the rules are you've defined before you go and deploy it. So if you start thinking of infrastructure as code in a very DevOps kind of fashion where you might want to deploy through a pipeline, I could now look at where CloudFormation Guard can help head off compliance issues before I even attempt to deploy them. So that one's in preview now and definitely worth looking at if you're in that infrastructure as code space. Next up, AWS Certificate Manager extends the automation of certificate issuance via CloudFormation. I'm actually a big fan of this one because I've had to write code to do this on a couple of occasions. Previously, when you wanted to use Certificate Manager to get a certificate at no cost that you can use in Cloudfront or other public AWS endpoints, you would need to validate that you own that domain. And that was typically done either through email validation, which is less preferred, or through DNS validation. So you'd have to go and create DNS records before we could validate that and issue the certificate. Now, if you're using Route 53 for your DNS provider, you can simply specify the hosted zone ID in the CloudFormation, and we will automatically add the DNS records for you to do that validation. This means that you can get an end-to-end provisioning of the certificate and validation without having to write any custom code. And as much as I love writing code, no code is better than code. Okay, next up, AWS App Mesh Controller for Kubernetes is now generally available. So again, if you're a Kubernetes developer and you're running a Kubernetes cluster literally anywhere, you can now install the App Mesh controller for a native experience in Kubernetes that can allow your Kubernetes cluster to be connected to App Mesh. What this allows you to do is define services within that will be exposed into Service Map and then accessible through App Mesh, but also make it really easy to take advantage of the things that App Mesh gives you, such as describing failover between services and automatically enforcing things like encryption and transit between your services as well. So again, a really great way to onboard to App Mesh for anyone who's running with a Kubernetes workload. And the last one this month is the AWS Solutions Construct Library was released. So we've had a couple of presentations about the AWS CDK, and we've talked about it over the months and a while now since it's gone generally available. What we've got now in this solution construct library is a bunch of common AWS patterns that have been written as CDK constructs that you can implement by just pulling in that construct instead of coding all the individual resources yourself. Say, for example, you wanted to create an S3 website behind Cloudfront. There's a pattern for that. If you wanted to create a Lambda function behind an API gateway, there's a pattern for that as well. So this makes it even easier to improve your developer productivity when creating CloudFormation templates to be able to really get in there and get moving quickly without having to jump through the hoops of creating the individual templates yourself. All right, so again, we're still sort of in a fairly remote world, so I haven't been listing out training courses that are happening in Canberra at the moment, but there are still a lot of virtual classroom live sessions. So again, if you're interested in taking on more AWS training at the moment to help upskill yourself or get yourself certified, head to aws.training, filter it by the course you want to do, and look for Virtual Classroom Live. You'll find a number of courses that are in the Australian time zone that will be able to help get you upskilled and get you moving. Okay, on to white papers for this month. Again, a lot of white papers, a bunch of new ones, as well as some updates. A couple that I'll call out. We've been talking about deploying Amazon Workspaces a lot lately with some of my customers, so it's worth noting that that guide's been updated. We've got an interesting one for developers around pull request continuous integration and how you can work with some of that inside of AWS. The security incident response guide. If you're in security and you're managing security of the cloud, that is absolutely a white paper to have a look at, and that's been updated this month. And lastly, there's also a new one in there around accreditation models for secure cloud adoption. Again, if you're in that security space, and particularly around security and compliance, that's a white paper that you definitely want to get your hands on and have a bit of a read. So at this point, I'll start to wrap up my intro a little bit, and we always like to ask, what do you want to hear? If there's a particular topic that you're interested in hearing about, be it a service or some sort of solution or anything like that, please let us know. Also, if you've got something that you'd like to present to us, I absolutely want to hear from you. We always on the lookout for people who want to get up and talk about some of what they've been doing with AWS. And in fact, that's exactly how Andrew found us for tonight's presentation. So please always reach out and let us know if you're keen to present, because we'd love to have you. Also, submit your feedback each month. I was looking at the numbers today. One of the things I've noticed since we've gone remote and we've been doing this on Twitch, less of you are doing your feedback, but we really do pay attention to it, and it really does mean a lot and helps us tune what we do with the group. So if you can make sure that you submit that through Meetup after each month, that would be really awesome. And lastly, friends don't let friends, Mr. AWS User Group. I say this every month. Word of mouth is our best mechanism for spreading word about the group and what we do. So if you like what you see tonight, go and tell a friend. And hopefully they'll then like it and they'll tell a friend as well. And before you know it, we'll be swamped with people. So without further ado, at this point, I'm going to hand over to Andrew Hammond to talk to us about the truck driver fatigue solution that he's built in on top of AWS. Andrew, would you like to introduce yourself?
Oh, yeah, good day. Thanks, Brian. So, my name is Andrew Hammond, and during the day I run a small consultancy here in Canberra called KJR, but of an evening I tinker with AWS and, looking at truck driving or managing fatigue in our heavy vehicle truck drivers. So, it's an interesting project that has an interesting story in terms of where or how we started. So, I think Excellent. I'll probably run you through that to start with.
Share your screen and we'll hand it over to you.
Yep. Okay. Screen share. All right. So truck driver fatigue, I just thought I'd play this little video here. Hopefully you can see that. Here it comes. And so essentially this happened to be a vehicle I was heading to Sydney that I was following, and this particular truck was a bit all over the road. And I think we've all had that experience where we're on the highway and we're cruising along and we can see a truck or another vehicle. So it's not just limited to trucks that has a fatigue or what looks to have a fatigue event, and you can see them going across the road. So one of the most interesting things about fatigue that, if you haven't seen already, is that it is actually one of the top three killers. The others is speed and drink driving, essentially. So it's claiming a lot of motorists on our road. And unfortunately, last year in 2019, it was the #1 cause of truck driver deaths, which is quite sad. So 18 out of the 58 drivers died because of fatigue-related incidents, essentially. The other thing and this will sort of make more sense in a moment when we get to it, but essentially cardiovascular disease as a predominantly male industry. The truck industry employs more males than any other industry. And males, generally, we don't have the best habits of looking after ourselves and going to the doctor and stuff like that. And truck drivers in particular have quite a sedentary life where they're sitting still for large periods of time, don't have access to great facilities along on the road and stuff like that. And what tends to happen is we have quite poor health, and it actually is costing all of us a whole lot of money. It's is the largest burden on our hospital system in terms of dollars, but also, as you can see there, the stats there, 1 in 4 deaths was due to cardiovascular disease. And the Heart Foundation has actually said last year, essentially, that most cardiovascular disease is actually preventable, which makes it even more problematic that we're spending so much, or having so many deaths, but spending so much on it. So our story starts about 2 years ago. So in April 2018, we entered a hackathon competition called FatigueHACK. It was run here in Canberra by the Australian Trucking Association and as well as facilitated by CBR Innovation. And essentially, as you can see there on our screen, our product pitch, we had Amazon clearly right in the middle of the solution. But essentially, our pitch is to use the driver's own biomarkers and bioindicators to judge their level of fatigue and then predict how that fatigue is going to play out over a 1 to 2 hour horizon. Because what we found is when we're chatting to the drivers is that most of them understand how they feel when they're fatigued. You know, their knee gets itchy or their shoulder aches or that sort of stuff. So that bit they're quite good, but they don't necessarily understand exactly where am I going to pull over a 26-meter B double or a road train or a truck of any size, because you can't just pull them over on the side of the road. And that's where our journey started. So our original vision here, I've just grabbed this out of our slide deck to sort of highlight the solution and the concept that we had just over 2 years ago. So essentially, I guess AWS in the middle, but a whole bunch of trucks out on the road that were capturing information. The information that they're capturing, you can see there in the top left-hand side there with the ECG markers. So essentially geo information based on GPS. Video camera feeds for what's out in front of the road, and also facial or markers of who's the driver and what are they doing. And then in the truck, which I'll show you a picture of in a moment, our concept was to have some machine learning going along, actually doing some of the calculations and providing notifications back to the driver and the Teletrack Navman unit down there below, just to present the information. So that was the pitch that we went in for with, I should say, to the competition. And as luck would have it, we ended up winning. It was a crowd-based vote, so there was 300 delegates at the FatigueHACK presentation session, and they were all truck drivers or truck owners or fleet managers in OH&S. So and I think we, out of the 300, I think there was only 10 votes in it, so it was very close. Interestingly, one of these things, I'm not sure whether you all believe in fate, but a curious story that we have here. So the picture of all the trucks down the bottom, which appeared in our presentation 2 years ago, ended up actually being our first customer. And when we did it, we quite legitimately just pulled that pulled that picture off the internet just as a representation of what a fleet of truck looks like at a depot. And lo and behold, about 12 months later, the team at MultiQuip reached out and asked us to come and show us the technology and start to work with them. And unbeknownst to them, it wasn't until we had the first meeting that we actually saw, they actually saw, they're like, oh, that's our trucks, how'd you get them in there? And explain the story. And it's quite an interesting sort of, they were interested in our solution and we had them in there from the get-go. So it made for a good sort of start. So our particular solution, so what we've got is it all relies on a custom built steering wheel. So essentially you can see there on the top left, that's one of our steering wheels installed in actually in that truck that appears on the bottom left, which runs out of Mitchell, just down the road from my place in Gungahlin. And so the way that it works is, most of you will be familiar with a treadmill, as if you're on a treadmill and you're running on a treadmill and has the little stainless steel pads, and you grab the pads and it measures your heart rate and tells you that, how fast your heart is beating and that sort of stuff. It's exactly the same concept as though we've just embedded it in a steering wheel. We've also built the little FatigueMate unit you can see there on the right-hand side, which is a Raspberry Pi in a case that's deployed to the dashboard to capture the front camera feed. The Raspberry Pi unit and the design for all that's a Canberra-based company that's done the prototyping and printing here. So that sits in the truck and the truck cruises around. That one cruises around Canberra. I've also got one installed in my car, and there's also one that's in a truck that's based out of Marulan, collecting data at the moment. And so the truck runs around as the truck, depending on the model that we've got installed. Some of them have their own onboard 3G or 4G dongle that pumps the data straight up into AWS S3. Others have a back-to-base Wi-Fi unit that when the truck returns to the depot, as it comes in, it connects to the Wi-Fi and starts to upload all of the data into the S3 bucket. So the current state, and this is where we'll start to dig into the details. The current state is we've got the ECG working, we've got the GPS tagging all of the observations we make, and the front-facing camera also in play and collecting data. We're working on the facial recognition component. It is quite a fascinating area from an organisational change perspective. So I was actually only chatting to our driver on yesterday, and they're going through a process where they're putting cameras in that face the drivers, and he was really quite anti the essentially the big brother keeping an eye on what he's doing, because one of his mates that already has the gear installed said he reached down to get his drink bottle, and so essentially had his eyes off the road for a brief second, and that sent an alert and a video to the boss, and the boss was ringing him saying, "What are you doing?" And that sort of stuff. Whereas when we spoke to them about putting our solution in, which doesn't capture the driver in a camera-based manner, they were like, "Oh yeah, just put it on and we'll be fine." So this is really sort of interesting cultural change piece that's going through the industry around how or what sort of information is collected and how it's collected. So, and so I thought we'll dig in and have a look at the actual solution in terms of how it works with the AWS component, which is at the core, or is actually the core backbone of our solution. So I'll just jump over to a live demo of S3. And so I'm assuming most of you are familiar with the basic construct of AWS. So our solution, so the first S3 bucket that you saw is the FatigueMake data store that we've got here. And so this is where the data all gets dumped into in terms of its raw format based on the different truck and device. And so each of these buckets is a truck or in my case, a car. And so you can see there's quite a few of them at the moment, and so in there we have a different folder, and you'll see the evolution of our system essentially. So when we first started here, this is an epoch, a Unix epoch time, and then so as we've matured our solution, we've actually gone down to actual dates, and so for each day that the vehicle is out and recording data, when it comes back, it uploads it into the S3 bucket, and there's a mix of data in here. So you can see there's GPS there. Some JSON files, which will become important shortly, some text files, which is mainly data that's captured by the ECG, and also images there. So that'll be the front camera, and being number one image, it's probably just outside my house essentially. So you can see just driving down the road, no traffic there. And why the road conditions are important is that each driver responds to road conditions differently. So I'm a relatively stress-free sort of a guy and that sort of thing, so traffic doesn't bother me. But what we've seen in our drivers is sometimes if they're stuck in traffic and lots of traffic, obviously driving a truck, the heart rate and the body's response to that traffic and the stress of being in the traffic changes quite noticeably, essentially. So so that's why the camera's there, and we'll get a bit more of that in a moment. Oh, sorry. So the data all goes into the S3 bucket here, and there's actually a Lambda function that runs when the data hits this FatigueMake data store. It's a very simple function, and what it does is it actually reads the files that are going in and picks up the JSON files and then transfers them into the data lake, or what we've called a data lake. And this in our S3 implementation, it's quite raw, in some ways quite immature, because we're sort of feeling our way through how we construct these. So while we've called it a data lake, and I know there is products in AWS that are an actual data lake and stuff like that, so we've just named it that way. But what we've got in the data lake is that we transfer the data instead of in the raw format where it's vehicle and time based. In the data lake, we're moving it into the different observation areas so that we can report on them in aggregate. So you can see we've got camera there, ECG, fatigue, the FatigueMake data score, and RR metadata. And so RR metadata is the different, so as your heart beats, there's an R peak, which is the height of the beat, essentially, and that's what gives you your heart rate. And so that's that metadata. So we'll step into that a bit later on. But essentially, so once we go into the metadata, we've changed from device, date, whole bunch of data to the type of data, the date that it was collected, and then we'll just pick a random one here, and then the device that it was collected on, and that gives us a lot more gives us the ability to do a lot better reporting. And when we start to present that in Athena, then it makes it a lot easier. And so I'll just jump over into Athena. So the data from the data lake gets ingested by, at runtime by Athena. And so what we've got set up in Athena is a bunch of tables. And so this gives us the ability to look at the data. If we want to look at all of the camera images, or all of the ECG, or all of the others, we're able to do that and then aggregate that by date and then by device. It works out quite nicely. So if we have a look at this one, just as an example, so all of our JSON files have the same format. So they've got the session details and the payload. And so in the session details, and a session is a day essentially that we've been running the vehicle, has the device name, some GPS coordinates, the time it was written, speed, and a few other things, essentially metadata about the record that's being written. And then we have a payload. And in this instance, we're looking at the camera payload, so it has a bit more data in there, but also in this instance it gives us the name of the file and the location of the file. So if we want to present it later on through our website, we're able to present it without too much need for more coding, essentially. And so so that's the table. And essentially what I found when I was learning Athena and learning how to use Athena was that it was quite challenging to get complex data presented straight away. And so this is how I ended up with the table, which has the session and the payload, as well as we'll jump in here into the view, which is a different view on that table, which actually starts to bring in the columnar data, I should say. And so you can see in here now we've actually got distinct columns for the device, session, time written, speed, and the data there. So that becomes really important, or makes it a lot easier for us to then actually do some reporting on it. So now you can interact with this in a manner which is familiar, certainly familiar to me, using SQL and SQL type queries. So we found that to be very useful, essentially. And so when we look at the ECG metadata here, what I've done is tagged some of the data as being valid, essentially, because we get lots of data and we get lots of data that's not valid. But the valid data is the stuff that we really want to look at. So in the view, we're able to take a filtered look at the table and then just drag out the actual data that's relevant for the queries. And you can see that data is, just by looking at it, it's actually a lot better populated than the previous data set. So the great thing about Athena is that you only get charged based on the queries that you run. And so it's only charging us when we actually execute a query against the S3 bucket, as opposed to a DynamoDB that we started to look at in the early days. But as soon as you create the DynamoDB, you're starting to pay for storage and the use of it. So the ability of Athena with the data we had is a very cost-effective solution as well. And so the Athena, is pretty cool, but the actual usefulness of Athena that I found and what we sort of transition through here is actually to use QuickSight. And so hopefully a few of you have used AWS QuickSight, which allows you to get quite readily or quite easy to get business analytics through. And so what we've got in terms of our data is that each of those views that I was just showing you in Athena is actually mapped to a data set in QuickSight. And so these SPICE data sets you can see here, those data sets are actually imported into QuickSight every night on these particular ones. And so what happens there is that it's essentially grabbed out of Athena and stored in SPICE to make sure that the queries that run in QuickSight are far quicker, because it's only querying the data that it has there rather than going back to Athena and back to S3, which is really good. And so you get the ability there to look at the data set and edit the data set. And I've had to massage some of the data just a little bit in terms of getting it to behave the way that we want. And so essentially As you can see here on the left-hand side, there's some calculated fields. So I've actually calculated based on the date, based on the session here, we calculate what day of the week it is, and the elapsed time is how far through the session it was. The other thing that we've told it is that the session is a date, and the lat and long are actually GPS related. So you get the ability to actually interact with the data and modify the data in an ETL-like manner as part of this process. So that made it a lot easier for us to manipulate in the actual dashboards and stuff like that. So how this all sort of, in terms of the process, and I'll dig in a little bit, but the dashboards, which is the piece that we really are interested in terms of where we're up to in the process, in our project, I should say, what we want to see is how much data are we actually collecting each day. So this particular graph, set of graphs here actually queries in real time Athena and then S3 to see how much data is being uploaded. And the reason that we did it this way, as opposed to having this one as one of the Spice data sources, is that I can jump in, or anyone who's got access can jump in at any time of the day. And after a little wait, it'll actually tell you what data there has been uploaded for that particular day. And so we can see if one of the drivers has forgotten to turn on the system, or there's been an issue or something like that. We can start to see just an aggregate based here. And so you can see that in this particular example, the FCAM is the front camera, and it's the one that has the most data in the system, essentially, because as soon as the truck turns on, it starts capturing the images, and it's sort of a good lead indicator as to how much of the other data we should see during the day. And so, yeah, this is just, again, querying different those different JSON files. Probably the one that is the most interesting, or gets the most interest, is when we start to plot where our drivers have been during the day. And essentially, I wrote a blog post on this not too long ago around looking at the geographic patterns that we're starting to see. So in this instance, we're looking, and you can see the grey dot is my car, and the black dot is the truck over the last 2 weeks. And these are where the valid ECG records have been captured. And so if you look at this over the last 2 weeks, it's not particularly, I mean, it's interesting, but it's not, not particularly, it's not giving you many insights. But when we start to use the power of QuickSight and having things plotted on the graphs and stuff like that, you can start to see quite a bit of data. And the key insight that we have from this particular graph, looking at this, is about where's our valid data being collected. And if you think about someone driving and holding two hands on the wheel to actually capture the valid ECG signal, what is immediately obvious to me in this instance is that most of the roads where we're getting good signal captured are 80 k's an hour, or 80 to 100 k's an hour. As you look at the Majura Parkway on the right-hand side there, or the GDE and Tuggeranong Parkway on the left-hand side, and a couple of the arterial roads there, not as many good ECG signals being captured in the suburbs. And so if we look at Gungal, just because that's the neck of the woods that I am, essentially lots of good ECG around my house, but not so much in any of the other suburbs. Periodically there's a little bit there. And so from a business point of view, now we're starting to look at this data and say, okay, based on that, what's the best type of vehicle and truck driving scenario for us to deploy in to capture good data, and then have more conversations with our drivers around that sort of thing. Equally, if I go out to, if we just do it, out to years, what we see is very similar, except there's a lot more, if we zoom out a little bit, we start to see, we've captured data from Sydney to Melbourne and down to Thredbo in the snowfields. And again, this is sort of gives us a good indication of, okay, well, where are we capturing good signal from our drivers? And again, that's about, refining our business model and our analytics as we go forward. Another cool graph to look at from a sort of a health perspective is our heart rate analysis. So the whole premise of what we're doing in the ECG is we're looking at the variation between your heart rate. So your heart, when we talk about beats per minute, the in between each beat of your heart is actually different timings, and depending on how spaced out or how uniform those timings are, we can actually start to tell a lot about how fatigued a driver is, or the particular sort of pressures on their heart and stuff like that. And so this RMSSD is the root square mean between heartbeats, essentially. And so what we want to see in a driver, and you as an individual, it's not just drivers, is that your heart is responding to different stimuli during the day, essentially. So a flat RMSSD is not good. So what we want to see is a bit of variation in there. Likewise, you can see here on the left-hand side, average heart rate over 2 weeks. You can kind of see one driver quite flat and the other quite a bit different there, essentially. So, and in the instance that the flat heart rate is actually mine, essentially. So my heart rate, I haven't been doing a lot of cycling at the moment. So when I've been driving, it's been quite low at my resting heart rate. Whereas our driver, who's been in and out of the truck quite regularly, you can sort of see different bits of different times of the day his heart rate has spiked, and that's because he's been getting in and out of the truck and has quite an active lifestyle. And I think the good thing, or the takeaway from this particular or any of these particular slides, is that once you've got your data in Athena or even in S3, you can drag it into QuickSight quite easly and start to do some analysis and actually provide business value back to your business and start to generate some insights. We can then make business decisions from that. And so from a fatigue point of view, one of the graphs I had up earlier was one of the points I made earlier was it's killing a lot of our drivers, and what we're starting to see in our data and starting to look at is, well, what are the trends? And so in this particular instance here, we've got some speed factors, essentially. So in this instance, we're seeing a lot of our data is captured when the vehicle's doing less than 80 k's an hour, is that one. And so less going fast, which is good. And equally in terms of distance traveled, so most of our data is being captured on short trips. And where this starts to make or become useful is when we start to look at what our colleagues in industry are finding in terms of their research. And so there was a fair bit of information that's just been published. Just jump in by for this national major accident investigation, and they start to talk about different sort of crashes by fatigue, well, in terms of fatigue, but also speed, location, day of the week you would have heard me talk about earlier, and location and stuff like that. So you can see fatigue here is different locations. So in terms of what we're starting to see based on the collection in our vehicles, but then also our ability to then present these insights through QuickSight, we're starting to actually pull together a picture of fatigue and how we can then start to manage fatigue and overall driver health as well, because that's a healthy heart gives makes a healthy individual. So it's the advantage for us is that we've also been able to do all of this with our in terms of our setup and that sort of costs. I'm pretty sure our Amazon bill is, it's $50 a month. I think it is, maybe 55 at the max, essentially. So, and we're not the biggest users of it, but geez, we're getting some value. We're getting much more value than what we're paying for in terms of the use out of the tool set. So it's it's from our point of view, it's pretty cool. We do have, as I alluded to earlier, with the images that we're capturing from all the data, I should say, but specifically the images that we're capturing out the front. We do have a couple of machine learning algorithms that are running. They're not running routinely at the moment because we're still getting up to speed, looking at how what's actually happening out the front of the truck, then starting to classify the road conditions and the weather conditions based on what we're seeing there. And we're also starting to look at using SageMaker to actually start to do some machine learning on the ECG signals that we're getting and how we can use the machine learning to identify what's a good and a valid ECG, as well as start to predict what the particular driver is looking at, and sort of in this sort of summary information. We've got a whole lot more detail, which I won't go into today. But, in terms of if you take me for an example, if I'm driving and all of a sudden my heart rate, at 6 o'clock in the morning is 110, then we're able to, and it's sustained at 110, then we're able to start to talk to our drivers about what's actually happening in the vehicle. Did you have a bad night's sleep? Is it stressful? And start to use that as a baselining mechanism. And that's where we think our machine learning is at a very simple level at the moment, but we believe it's going to get quite complicated, or complex, I should say, and deliver us some really good insights based on the merging of all the information that we've got. So yeah, so that's the overview of our journey thus far and where we're up to with AWS. So was there any questions or any areas that people wanted me to drill into a little bit more and have a look at that? So I can see a question there from Lemon Drink. So exactly right. For those of you that can't see it, are we looking to personalize what good looks like for each driver? Someone may have a higher resting heart rate, for example, and that's exactly right. So you can see in the graph that I have open at the moment, there's my heart rate versus one of our other drivers, and the model will be personalized for the individual because we all respond to, so we all have different cardiac responses, but equally, and we're a little ways off this yet, but you can actually, your heartbeat is almost, or has been proven, I should say, to be as unique as your fingerprint. So we will eventually be able to tell which driver is driving a vehicle based on their signature in their heart rate. But equally, definitely, there's not much point in us trying to apply the model for myself against our other driver whose heart rate is, on average, about 25 to 30% higher than mine, because otherwise we'd just be having a constant conversation, calling him saying, are you okay? And so we're building a model at the moment that looks at what the individual, what their heart rate and also the heart rate variability looks like for them over the hours of the day and even across the days of the week, because we do see some patterns. I didn't tag this graph, but we do see some patterns around the days of the week. And that's not the right one, sorry, which day of the week it is and how much, I think it's this one, and how much data we've got collected and the hours of day. So yeah, definitely. Another question there from Paul, are we planning to leverage CloudWatch for alerting? We are, and I must admit I had a bit of an epic fail the first time I tried to use CloudWatch for alerting. So I thought I'd put in an alert for every time a new session was created, so in S3, but I didn't quite get my query and my setup correctly. So I ended up with like thousands of email messages because essentially instead of getting it, so as I just find it here, so I thought I'd be clever and set it up so that each time a new folder was created, it would send me an email, but I didn't get the regex expression quite right. So each time a new object was added, essentially under this FatigueMaker data store, I was getting an email and an SMS, which fortunately I worked that out while I was actually testing it. I hadn't turned it on live yet because that would have been a little bit embarrassing. So, but yeah, definitely we want to use some more alerting and get more advanced in our the operationalized elements of the system. So yeah, that's a great question. Thanks, Paul. Any other questions?
All right. I think that will about do us. Awesome. Thank you so much, Andrew, for coming along and presenting for us. That was a super interesting session there. If anyone's trying to reach out to you afterwards, is there a preferred way that they should reach out to you to get in touch if they've got questions or anything else?
Yeah, just my email address, which is we'll put in the show notes, I suppose, is the way we talk about it. Yeah, andrew@augmented-intelligence.com.au. So, or hit me up on LinkedIn. It's probably another easy way to find me. So, but yeah, it's fun. One thing, two things I love doing. One's drinking coffee, and two's talking about different projects we're doing, and particularly, with the experience we've had with AWS. So I could talk all day. So yeah, that'd be be great.
Awesome, excellent. Thank you so much then. So everyone else, please submit your feedback. I know you're still watching. I can see the numbers of people on the stream. So again, we are really, really interested in getting that feedback. Otherwise, thank you so much for spending some time with us on the Wednesday evening, or if you're watching this on the recording, whatever time of day it is when you see this. We will be back again next month with another presenter, so keep an eye out for us. Make sure you subscribe on Meetup if you want to receive notifications about when we've got things upcoming. And otherwise, thank you so much, everyone, for coming along. Cheers.
Cheers. Thanks all.